Hello students, in this video we're going to learn how to solve problem sum involving number patterns. Do get ready a pen and some papers and practice along with me. Let's look at some examples. Let's look at question 1. Question 1 has 3 parts, part A, B and C, and they are all not related to one another. Let's look at part A first. So part A, we're given the sequence comprises of the number 0, 2, 5, 9, 14, 20, and we're asked to find the next term in the sequence. Right, so let's examine the sequence. You'll see that 0 plus 2 will give you the second term, and 2 plus 3 will give you the third term, 5 plus 4 will give you the fourth term, 9 plus 5 will give you the fifth one, 1, 2, 3, 4, 5, and 14 plus 6 will give you the sixth one. So the seventh term, you will have to add 7. So this will be your seventh term. Let's look at part B. So for part B, you're given the formula. This is more like a formula to find the number of terms, right? So n represent the number of terms. So I can let n equals to 1. That is the first term. When n is equals to 1, we are referring to the first term. And if I substitute n to be 1 into this kind of a formula, you can call it, you get the first terms to be a negative 3. And if you let n equals to 2, you will get the second term to be negative 1. If you let n equals to 3, you will get the third term, which is 1. If you let n equals to 4, you get the fourth term, which is 3. Right, so if you look at this sequence, you will see that we just need to add 2. For example, negative 3 plus 2 will gives you negative 1. Negative 1 plus 2 will gives you 1. 1 plus 2 will give you 3. So to get the 13th term, all you need to do is just substitute n equals to 13 into 2n minus 5. And that's how we get 21 here. Right, so that's how we do part B. Let's look at how we do part C. So for part C, we need to find the formula. When it said write an expression, what they're referring to, it's writing the formula, something like what we have in part B, 2n minus 1, where we can substitute the values of n to find each term. So let's look at the patterns. So this is what number patterns is all about. To come up with the expression, we need to look at the pattern. So the first term is 7. Second term, it's 12, 17, 22, 27. You'll see that to get the second term, basically you just take 7 plus 5. Every term you just 7 plus 5 gives you 12, 12 plus 5, 17, 17 plus 5, 22, 22 plus 5 give you 27. So you see that I have a plus 7 here. Right, and then to get the first term, and then you will see that 7, 12, 17, 22, 27, that if you were to minus away 7, five, 17 minus 7, 10, 22 minus 7, 15, 27. Okay, so you see all this 0, 5, 10, 15, 20 have common factors 5. 0 is 0 times 5. 5 is 1 times 5. 10 is 2 times 5. 15 is 3 times 5. And 20 is 4 times 5. And we can further break down 0 to be 1 minus 1. 1, you can break it down into 2 minus 1. 2, you can break it down into 3 minus 1. And you see that this 1 here represent the terms. That will be your first term. 2 represent the second term. 3 represent the third term. So therefore, if you want the nth term, it will have n minus 1 times 5 plus 7. And that gives you 5n minus 5 plus 7. And that gives you 5n plus 2. And that's how we get the expression. Right. But in the exam conditions, sometimes it's rather difficult, right, to come up with the analysis like adding 7, the kind of thing, getting the common factor 5. So therefore, for such questions, we do have a formula to find the expression. And the formula is it's very easy. The formula is just A plus bracket n minus 1 times D, where A is the first term in your sequence, which in this case here is the number 7. N minus 1 is fixed, you don't change it. D refers to the difference between the first and the second term. The difference between the first and the second term. So your first term is 7, second term is 12. So 12 minus 7 will give you 5. So you multiply by 5. And you simplify it. And you will get the same answer as what we found earlier on, where we break down every number into some kind of a logical steps, and then you derive the patterns, and from there you derive the expression. All right, let's look at the next questions. So the next questions, we are told that in a sequence, each subsequent term can be found by subtracting 6 from the previous term. Right, so in part A, you are given the first terms to be 53. Right, so we have 53 to subtract 6. So 53 minus 6, what do you get? Yes, you get 47. And then 47, take away 6 again, get 41. 41 take away 6, get 35. Right, so it says to find the next 3 terms. So this will be your next 3 terms. Let's look at part B. So for part B, we're asked to find an expression, right, like a formula to find the nth term. So the nth term could be the 6th term, could be the 7th term, etc. Right, so we need to come up with a formula. So if you recall what we have learned in the earlier slide, the formula would be 8 plus bracket n minus 1 times d. Now this formula, you can only use it when you are doing a linear kind of projection. For example, like you add 3 to every term, add 3 to the first term to get the next term. That means for every terms, it's just add 3, add 3, add 3, add 3, or add 2, add 2, add 2, add 2, or minus 6, minus 6, minus 6. Okay, you do additions or subtractions using the same number, then you can just use this formula, right? If you have what we had just now earlier on in the earlier slides, where the first term plus 1, second term plus 2, third term plus 3, fourth term plus 4, then you cannot use this formula. Okay, this formula is applicable only when you have things like plus 2, plus 2, plus 2, minus 6, minus 6, minus 6. Okay, right. So A represents the first term in this case here, which is 47. And D represents the difference between 47 and 41, which is negative 6. Because 47 minus 6 then is 41. So your D has to be negative 6. This is very important. If you don't substitute this correctly, then you won't get your answer. Let's look at how we do the next step. You would have n times negative 6 gives you negative 6n. Negative 1 times negative 6 give you positive 6. And if you simplify further, you would have 59 minus 6n. So to check your answer, this is what you can do to check if you have got the correct answer. Right, so this is the like a formula. So when you substitute n to be 1, you see that you get 53, which is what we are told here, the first term. If you substitute n to be 2, you get 47, which is what we here get for the second term. Right, so let's look at the next question. So for the next questions, you're given 4 terms, 11, 20, 29, 38, and we asked to find the expression for the nth term. So let's examine. 11 plus 9 gives you 20, 20 plus 9 gives you 29, 29 plus 9 gives you 38. So we are very lucky, as in this is a linear kind of a sequence. So we can just use this formula. So A represents the first term, which is 11. D represents the difference between the first and the second, which is 9. If you're not comfortable doing something like this, you can just bring the 9 to the front. Because after all, 2 bracket 3 is the same as 3 bracket 2, which is the same as bracket 2 bracket 3. You know, you will get the same answer. That will give you 11 plus 9n minus 9. So 11 minus 9 will give you 9, 10, 11, 2. So this is the formula for part A. And you can always try to check if your answer is correct or wrong by substituting n. If n is 1, 9 plus 2, it's 11. N is 2, 18 plus 2, 20. N is 3, 27 plus 2, 29. Okay, so we're correct. Okay, let's look at part B. So part B, we are told that if you were to keep continuing to find all the terms, 100 of them maybe, one of them is 335. And we want to know which n represent the position, right? We want to know n is equals to what number, at what position is n to get this 335. So all we need to do is just to let 9n plus 2 gives you 335. And from there, you will have 333. N will be 333 divided by 9. Gives you 37. So what we are saying here is this is n equals to 1. This is n equals to 2. N equals to 3. Continue until n equals to 37. And here at this position, it's your 335. This is what it means. Okay. All right, let's look at the next question. So for the next questions, you are told that the same number, okay, you're given a sequence 39 PQR11, and the same number is being subtracted, that means 39 will be minus a number which we don't know, we call it x. P minus x, Q minus x, R minus x will give you 11. So you ask to find the values of P, Q, and R. So since it's the same number that's been subtracted each time, right, we can just take 39 minus away 11 to get 28. So this 28 will be shared by the last four number. 28 will be shared by the last four number. So when you take 28 divide by 4, 7. So in other words, 39 minus away 7 will give you P, and 32 minus 7, 25, 25 minus 7, 18, 18 minus 7 gives you 11. So this will be your PQR. All right, so let's write it properly. So therefore, P it's 32, Q it's 25, R will be 18. Right, so this is how we do part A. Right, so for part B, we're asked to write down an expression. Right, so let's remember the formula. A represents the first term, which is 39. The difference between them, we work out to be 7. So it's a negative 7, okay, because you actually subtract. You take 39 minus 7 to get 32, 32 minus 7 to get 25. So make sure you put the negative there. And like what I've mentioned, if you're not comfortable having negative 7, you can just put it to the front. So you would have negative 7 times positive give you negative 7. This one here will give you negative 7. So this will be 39 minus 7 and this will be positive 7. So you would end up getting 46 minus 7n is the answer. Right, so similar like what we have done earlier on, we can always check to see if our answer is correct. You can just substitute n to be 1. So 46 minus 7 times 1, the first term is 39, which is what we have here. So we are on the right track. Right, so for the next question, we want to know if why is this not a term of the sequence. All right, it is not a term doesn't mean it is negative, does not mean it's not a term. Okay, like I have examples early on that it's possible to get negative number in the term, right? But your n, because your n represent the positions of the term, positions of the term, so your n, the minimum value is always an integer, right? The position, and the minimum value for your n has to be 1. That's n equals to 1, n equals to 2, n equals to 3. So you must understand the properties to describe this variable n. And it's a number greater or equal than 1. It's an integer, must be integer greater or equal than 1. So why is negative 246 not a term? So we're going to equate this equals to negative 246 and see if we can get a positive integer, positive integer for n. You see that you have 41 5 over 7. Right. Okay. So how do we explain it? So we say that since n has to be greater or equal, since n Since n is an integer, greater or equal than 1. Oh, wait, hang on. This is not how we explain. Since n equals to 41, 5 over 7 is not an integer, greater or equal than 1, negative 246 does not exist in the sequence. Alright, so that's all for this video on learning how to solve number patterns. Happy learning!